Okay, so we left off in the other video, previous video, explaining all this on the page. And up here, I didn't mention yes or no, but like false would be, I guess, no, and true would be yes. So there's many states, two binary states that can be used, but I was explaining in the previous video how our number system, using our number system, we can get an understanding how they were able to go beyond just 0 and 1, which is very important. Because the whole idea of explaining how we go from a binary to this is the whole point of this exercise. And so we got this combination. If you didn't or don't know, you could just go and look at the previous video. So we go with 8 different combinations here. And I want to show an example of how this helps out with computers. Now, basically, let me explain something. This is very simplistic. This is not an accurate, super accurate definition, but it's good for what we're doing. Computers take in input, right? This will be input. And they process this input. And then after they process this input, then it's presented to some output device. And then it loops back around and do it all over again so fast that you couldn't possibly understand how fast this whole process goes through, over and over and over and over and over. Some kind of input is processed, outputted, and then the cycle continues. So that's what I'm going to explain here with the keyboard here. These keyboards have a way for the computer to tell if you're pressing this key different than the other keys. And then some keys are double purpose. That's why they get these colors here. So they're double purposed. So anyway, the point is, using these combinations, I can make a matrix across here, and I'll draw it here like this for each one of these. If I get 8 of them, and then 3 of these right here. So when I press down on a key, it represents this point right here touching. When I press this key down, then that would be this point. So I can actually get, 3 times 8, 24 different keys. That means I can represent all of these keys. Wait a minute, 1, 2, 3, 4, 5, 6, 7, 8. All of these keys I can represent with just this little small group of numbers. So somebody press these buttons, the computer can take in input and do something that we told it to do. whatever it is that we programmed it to do, and then deliver some type of output. In this case, when we turn this calculator on and we press a number key, it will put a 1. So it takes in the input, sees that this key is pressed here, and then puts a 1 on the display. And it's just that simple. Now, obviously, there's more complicated processes, but that means you need more of these, and that's why the number of, and I wrote this down so I remember to mention this, these are called bit positions. So the more bits you have, the more complexity you can handle. More and more bits, more and more complexity. Right? Bit 1, bit 2, bit 3, bit 4, bit 5, several bits. Right? Bits of information, 0 to 1, 0 to 1, that's 1 bit. This is the second bit. This is the third bit. And it keeps on going. We had, in the early days, processors only had 4 bits. Then they got 8 bits. Then they got 16 bits. Then they went to 32, then 64 bits, which is where we're kind of at now. And then even more processors for military applications, 256 bits and 1,000 bits wide. They handle so much information coming in and process it and send it out compared to this. But I digress. The point is that because of this processing and because of these being able to be used in this way, we can actually go from 0 and 1 to something like this now. Even though we got this little fancy keys and all this, the bottom line is it's nothing more than something like this up underneath the hood. This may be 5 volts, let's say, and this may be, I don't know, another 5 volt line. Let's say they're all 5 volts. And then when they press down, then this becomes 5, only there. So 5 and 5 means it's this key. Whereas if this pressed down, then this will short this to ground, and this will become 5 and 5. And that's how you will be able to determine different rows or different keys in each row and column, by row and column. So I hope that makes sense. If not, just leave some comments and I'll try to do a better job. What else did I want to say? Oh, the display itself. Let's deal with this. You notice this 8 is actually like this, just like the keyboard. It's just a bunch of segments. Individual segments that either light up or don't light. Some kind of way for us to tell. Either light up or it don't light. Like in this case, they turn black, so they become, I think that's okay. One of the two, I always get that mixed up. So you can't see through, so it becomes black, and then when it's not opaque, or whichever one it is, you can see through. So that's how we get the different, like if we wanted to make a 2, right? That's all we do. We just turn on the energy or turn off the energy. Probably turn it on, I think makes it black. Right? Turn on the energy, and now we have a 2. And that can be based on one of these keys being pressed. Input, process, output. Put a 2 there. Put a 2 in the next column. whatever we told it to do, whatever the processing is. But this cycle continues over and over and over and over. Billions of times in 1 second. It happens so fast that if you compare its time to ours, it would be like us taking 1,000,000 years to talk to this. That's how fast it is compared to us. Which is a good thing, because that means we could tell it to do little small stupid things like this is touching, I want you to do this. And it can do it real fast and do other things like display pictures and dots, because that's how we end up getting videos and things like that. It's just a bunch of something like this, a grid with little dots that are different colors, and they light up. You tell it, put 5 volts here and 5 volts here, and then this lights up, right? Because that's where the cross sections are, and that lights up, and stuff like that. That's really all it is. But it started with 0 and 1, and there's still 0 and 1s going on, but it goes on in combinations like this. I hope this helps. If not, like I said, leave something in the comments. And that ends another episode of Learning Basic Computer Principles.